So in this video, we are going to be doing a top secret special sum circle, and it's going to help us with our sums and differences, but obviously I wanted it to all have the same sound at the beginning of the words. So help us with our sums and differences when we have to apply angle sum or difference identity, and we're using radians, because with degrees, it's a lot easier if you needed to figure out like what angles on the unit circle add to give you 200 or even 345 degrees. That's not on the unit circle, but 300 degrees is on the unit circle, 45 degrees is on the unit circle. I'll just add those. That could be my alpha and my beta. So if I need to find the sine of 345, I'll use my sine angle sum identity and do it. Bam. However, when you have an angle like 17 pi over 12, it's going to be a lot harder to figure out what radian angles add or subtract to give you 17 pi over 12. And you don't want to be that person that changes it to degrees first in order to do it. No. We're better than that. So we are making a special sum circle for your notebook. If you are interested in having it, you are more than welcome to copy this down and save it. And this way you will be the best in the class at figuring out all the things that add or subtract. Now, that doesn't mean that everything we put on this circle is like the be all and end all. There's more if we were to, go around the circle again, or if we were to do negative, but this will be a really good starting point. Okay. Now, what we're going to do, as in the box above my head, we're going to do denominators of 12, which are increments of 15 degrees. Those are the angles that you're really going to see in radians when you are given an angle sum or difference identity question. So 15 degrees, well, if you think about it, the whole circle around is 360. So 0 to 360, halfway is 180, halfway is 90. Well, 15 degrees goes into 90 pretty nicely. I mean, if we went halfway, that's 45. It goes into 45 pretty nicely. 3 times, right? Or even if it goes like 30, it goes into 30 kind of nicely, 15 and 15, right? So all you need to do is really just turn your brain onto radian mode, and we're going to put these tick marks around. I'm going to start off by calling this one 0 or 0 pi over 12. So we did this back in lesson 6. If that's 0 pi over 12, we've said the full circle has the value of radians that we found in our circumference formula. If you remember, circumference of a circle is 2 pi r. 2 pi is a full loop all the way around in radians. So that means, comma, coterminal to 0 pi over 12 is 2 pi, but we're trying to write this with a denominator of 12. So multiply on top and bottom by 12, we get 24 pi over 12. And then, pretty easy from here, we're just going to start chopping it up. What's halfway between 0 and 24 pi over 12? That's 12 pi over 12, which makes sense because that's supposed to be pi. What's halfway between 0 and 12 pi over 12? That's 6 pi over 12. What's halfway between 0 pi over 12 and 6 pi over 12? Well, right here, smack in the middle, that's 3 pi over 12. Now, we don't want to go halfway in the middle. That would be 1.5 pi over 12. That's weird. Or we could do half of it, so then you double the bottom. That would actually be 3 pi over 24. That's going to be half of 45, 22.5 degrees. We're not doing that right now. We're good with this. A little bit less than that angle, 3 pi over 12, we should be able to fit in 1 pi over 12 and 2 pi over 12. 1 pi over 12 and 2 pi over 12. All right. Now I'm going to keep going. That's same spacing. That's 4 pi over 12 and 5 pi over 12. 4 pi over 12 and 5 pi over 12. There's the 6. And now look how many tick marks we put into this quadrant. On the circumference of the circle in this quadrant, we put 1, 2, 3, 4, 5 tick marks. So I'm going to do the same thing here. I'll have 1 in the middle, and then I'll have 2 more right there, 2 more right there. That makes 5. I'll do the same here, 1 in the middle, 2 more right here, and right there. It's not perfect. I'm trying my best. Got 1 in the middle, 2 more and 2 more. And we're just going to keep counting all the way around, and we should hit every single spot perfectly. Then this is 7 pi over 12, 8 pi over 12, 9 pi over 12, 10 pi over 12, 11 pi over 12. We're doing great. Bing, bing, bing. 12 pi over 12. Keep it moving. 13 pi over 12, 14 pi over 12, 15, 16, 17 pi over 12. And that was the one that I mentioned before for an example of an angle. After that, we have 18 pi over 12, 19 pi over 12, 20 pi over 12, 21, 22, 23. Bam, 24 is at the end. Now, which one are the troublemakers, right? The troublemakers that are not on the unit circle. So troublemakers, I'm going to color coordinate, not on the unit circle. Okay, I'm going to highlight them, bold, yellow, troublemakers. So they're not on the unit circle. In other words, they don't reduce to have a denominator of 6, 4, 3, 2, or 1. That would be 1 pi over 12, or pi over 12. That would also be 5 pi over 12, 7 pi over 12, 11 pi over 12, 13 pi over 12, 17 pi over 12, 19 pi over 12, and 23 pi over 12. So if you think about it, they're even taller and skinnier like a tree than the pi over 3s. And then the 6s were close to the x-axis, but these are even closer because, again, these are increments of 15 degrees. So if we counted the degrees out, and I don't want to write them down because I don't want you to baby yourself and rely on degrees, but 15, 30, 45, 60, 75, 90, right? 105, 120, 135, 150, 165, 180, blah, 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 blah. Okay? So those are the troublemakers. These other peoples, they're the angles of the increments of pi over 6. So increments of pi over 6. I'm going to do one color, pi over 3. 4 should be next, I guess. Pi over 4 and pi over 3. So I will color those right now. First one, increments of pi over 6. That's going to be there, 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 and there. I'm going to write down what it is over 6 reduced inside the circle. 2 pi over 12 is really pi over 6. 10 pi over 12, that's 5 pi over 6. 14 pi over 12 is 7 pi over 6. 22 pi over 12 is 11 pi over 6. So those are all, at least between 0 and 2 pi, those are all my increments of pi over 6 right over there. Increments of pi over 4 can be next. I'm going to use green. That's going to be the ones right in the middle, the 4 in the middle, the 4 in the middle. And then I will write down what it is reduced inside my circle. These numbers should be familiar, and this is going to help us. Oops, I think I wasn't paying attention to what I was doing. I colored the wrong guy over here. Oh man, I'm gonna have to make sure I use a darker color at least. Maybe blue will be over here. Because if I white it out, you know that white out does not let me use the highlighter very nicely. So then pi over 4, so that reduces pi over 4. 9 pi over 12, I promise, reduces to 3 pi over 4. 15 pi over 12 is 5 pi over 4. And where am I? 21 pi over 12 reduces by, to become 7 pi over 4. So those are all my 7 pi over 4s, but with a 12 on bottom. And last to last are the pi over 3s, tall and skinny like a tree, until these troublemakers came in and were even taller and even skinnier. That's blue. Oh boy. Forgive me for that messiness. Okay, so if I count those out or reduce them, 4 pi over 12 is pi over 3. That's going to be 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. If we kept going, that would be 6 pi over 3, which is 2 pi, right? So 2 pi goes there, pi is there. Obviously, the top is that pi over 2. I'm just circling the quadrantals. And down over here, it's 3 pi over 2. That's great, but yeah, we probably won't need those too much for our special situation. So now, what do we need to know? What adds or subtracts, and there's more than one answer, but what adds or subtracts to give you 1 pi over 12? We need to know alpha plus beta, or we need to know alpha minus beta. Well, if I look at my circle at the 12s, I could figure it out. I always try to choose the smallest one possible. So if I want, I could do, for example, 4 pi over 12 minus 3 pi over 12. That would work, wouldn't it? And what's 4 pi over 12 really? Pi over 3 minus, and what's 3 pi over 12 really? Pi over 4. And like I said, we could always use pi over 4. So alpha and beta could be those angles right there. So I'm going to grab a different color highlighter just to kind of showcase alpha and beta. So alpha and beta. I'm going to do all the troublemakers. So if you ever have an example like this again, if you kind of have this in a good spot in your notebook, should I try to brighten it? Too bright. No, I think you could see that okay. But maybe the orange isn't quite orangey, so maybe I'll just layer that on a little bit more. I think it's okay. Can you see that all right? I think so. Okay. So then let's do 1, 2, 3, 4, 5, 6, 7 more. And we're going to move a little quicker. But how about 5 pi over 12? Look over here. What adds or subtracts, look at the numerators, 1, 2, 3, and 4, to give me 5? 2 and 3. 2 pi over 12 plus 3 pi over 12. That adds to 5 pi over 12, but what low key is 2 pi over 12? Well, 2 pi over 12, that's really pi over 6, right? And then 3 pi over 12 is really pi over 4. There's that pi over 4 again. Always pi over 4. So those could be my alpha and my beta. So yes, this is it, but we like it better as pi over 6 because that's more familiar. And then our beta, pi over 4, right over there. That adds to give us that 5 pi over 12. What about 7 pi over 12? What angles, not troublemakers, don't pick troublemakers, but what angles over here, try always to use the smaller ones if you can. And like I said, I always try to use the pi over 4. That's the 3 pi over 12. So can you do 3 pi over 12 plus or minus something to get 7? Sure. We can do 3 pi over 12, 3 pi over 12 plus 4 pi over 12. And what is that really equal to? That's the pi over 4 plus, and that's pi over 3. I will color those as alpha and beta in just a second. Just going to go over here and do that one. Again, my trick is to always use 3 pi over 12, which is a pi over 4. Super helpful. 3 plus what is 11? Well, 11, 10, 9, 8. 8 pi over 12. There it is. That's fine. It doesn't have to be in quadrant 1. So plus 8 pi over 12. And what's that reduced to? 2 pi over 3. So my alpha, and order doesn't really matter when you're adding, when you have alpha and beta. It does matter if you were subtracting. And you might compare your work to somebody else who maybe was subtracting instead of adding, or maybe they used different angles. That's fine, but I just like to be consistent. Oh no, I think I made a blunder because I wanted to use purple for this spot. every time for beta, so I will change that in a minute, but beta, 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 and beta. Okay? So are you able to tell me, without me telling you first, what adds or subtracts to 13 pi over 12? But remember, the trick, my cheap trick, is to always use 3 pi over 12 as one of them, which is really pi over 4, and then figure out what the other one would need to be. But while you give that some thought, I'm just going to change with whiteout my 3 pi over 12 and pi over 4. I'm going to highlight that in purple. All right. So what could we use? 3 plus what is 13? Three plus blank is 13. 10. 10 pi over 12. Yeah. So where do we find 10 on here? Is it here? Let's look at all my 12s. Yep. And what is 10 pi over 12? 5. So it's really 5 pi over 6. So behind the scenes, they could be written with the 12 on bottom. But when I do the work, who wants to think of it that way? Nobody. You'd rather have pi over 4 and 5 pi over 6 because you know those angles better. Okay? So there we go. So we're working them all out. There's all these troublemakers, and now we're figuring them all out. All right, this one, 17 pi over 12. Like, what numbers? You could really pick anything you want. There's so many possibilities of things to add and subtract to get that. But what numbers add or subtract to give us 17 pi over 12? Cheat way, cheap trick. One of them will be 3 pi over 12, which is pi over 4. And then what? 3 pi over 4, or I'm sorry, 3 pi over 4. 3 pi over 12 plus blank equals 17 pi over 12. And then what does it reduce to? Do you know?
Is it 14?
Yeah, 14 pi over 12. And then that reduces to give us
7.
7 pi over
12.
6. Yeah, when we reduce it all the way, 7 pi over 6. Boom. There's my alpha and my beta. So that circumference note was just on the sides. We remember the full circle's 2 pi radians. This is what we're doing. We're figuring out. Usually it adds up being an adding when I do it this way, but you know, in the future it could be subtracting, all good. The troublemakers are yellow. They're not on the unit circle. And we're figuring out what sum or difference of angles that are on the unit circle. So the orange and purple angles that I'm picking for these are all going to be either the salmon color, green, or blue angles when all is said and done. Okay? When all is said and done. So I might touch up and go back, and you'll see one of them is always going to be pi over 4 when I do it my way, and the other one will then be blue or salmon. It's either going to have a 3 in the denominator or a 6. A 3, a 3, a 6, a 6, and so on. Okay? Next we have 19 pi over 12. So I'm going to do my cheat. 3 pi over 12 plus 3 plus what is 19? 3 plus 16. So it's really going to be 16 pi over 12. Now is 16 pi over 12 on this circle? You bet your butt it is. Everything pi over 12 all the way to 24 is on this circle. So 16 pi over 12 is definitely on here. Where is it? There it is, 16 pi over 12. So that's what it reduces to. If you don't feel like thinking, it's already right there. 4 pi over 3. There's my alpha and my beta again. Perfect. So now when someone's like, oh man, what adds to give me this? Everyone else is going to be dilly-dallying and figuring out all this stuff. And you're going to be like, bam, I know, because I have it written down in my handy-dandy secret special sum circle. Whatevs. All right, here, last one. And this, like I said, doesn't mean that this is everything. There's always more angles that can be bigger or smaller. But 3 pi over 12. 3 plus what is 23 pi over 12? Yeah, and 20 pi over 12 is definitely on this circle too, because it goes all the way to 24. 23, 22, 21, 20. There's 20. 20 pi over 12, that's supposed to be blue. I know it doesn't look great. It's supposed to be. I'll try to fix it again. That's 5 pi over 6. 5 pi over 6. So now, the next time that I ask you to figure out with angle sum or difference identity, and I'm like, figure out what angles add or subtract to give you these certain answers, you should be able to do it much faster, okay? These are, I'm gonna circle this off to the side. There we go. All my 12s going around, right? I do have, like I said, I was gonna mark things up with blue, green, or salmon. So salmon is anything over 6. So where do I see that? Well, I have one right here. I have another guy right here. Let's circle it maybe like that. And 7 pi over 6 right here. It's a pi over 6 increment. That's over 3. This is over 6. There we go. Then the pi over 4s are in green. We should have one in every case because that's my method. It's basically a guarantee. Pi over 4. Oh, I was circling them, right? Okay. Oh, I have a meeting that I need to go to. Pi over 4, pi over 4, pi over 4, pi over 4. Got one everywhere, everywhere, everywhere. And last, in blue. Like I said, I'm going to fix this a little because it's a little messy, but that's all the ones that have a 3 in the bottom. So where am I using those? I got one over here. Got one over here. And that's actually blue. Not the best looking highlight, but I tried. Okay, so I know this is a lot of info in a circle, but I promise if you think about it and get the hang of it, I think it's going to become very helpful for some of you. So it's our special sum circle, top secret. Shh, don't tell anyone. And make sure you know your ordered pairs for the ones that are not the troublemakers. And if you know your ordered pairs, X is the cosine, Y is sine, and you're good to go. So if this was helpful for you and you think, what a special circle, thank you, put thumbs up. And if you're like, this was a waste of my time, put a thumbs down. I won't know who did it, and I will not be offended. Have a nice day.